Supercoils can be positive, coiling in one direction, or negative, coiling in the other. Positive supercoiling results from overwinding, like this rope. Negative supercoiling is the opposite. If you unwind a rope and then release the tension on it, it will supercoil in the opposite direction, creating negative supercoils. Let's consider what happens as DNA unwinds during replication. As DNA unwinds, it acts like this rope when we pull apart its two strands. As you pull the strands apart, twisting tension builds up in the rest of the coiled portion. It is actually adding one twist to the remaining rope for each twist pulled out of it. At some point, you can't separate the strands anymore. The remaining rope is too tightly twisted. If you relax your tension on the rope, it will twist around itself in a supercoil. It is releasing tension. If you want to keep pulling the rope apart, you have to release the tension periodically, and one way to do this is to cut the rope and splice it back together. This problem has been best characterized in small circular DNAs. There are two methods of dealing with this problem in DNA. One cuts only one strand of the DNA double helix, and the other cuts both strands. Let's look at the first. Topoisomerase I enzymes cut a single strand of the double helix, pass the other strand through the cut, and reseal the break, relaxing the overwound molecule, which now has one fewer twist. Topoisomerase II enzymes do the same thing but with both strands of the double helix. Topoisomerase II cuts both strands of a double-stranded DNA and passes another double strand through the break and then reseals the break. So if a molecule of DNA is supercoiled, topoisomerase II can remove the supercoiling, two twists at a time, to yield a relaxed